Okay, thank you. I think we are closing here the questions.
Okay, thank you. So we'll switch to the next presentation. Feasibility of on-site treatment of PFAS, contaminated groundwater, Western Netherlands. And the speakers are Jessica Meijide and Sònia Jou Claus.
Thank you very much for the introduction. Case Study 7 is located in northern Spain, where a site has been used for firefighting trainings since the 90s, leading the contamination to the aquifer by PFAS. This site, or this case study, is shared with another project named Life Source Project with similar objectives. They have similar objectives, but the main difference is that Promices proposes an in-situ method, an in-situ remediation, while Life Source proposes a pump-and-treat method. This is a map of the site highlighting two active, highlighting, okay, I would like to show this area, but you can. Highlighting two active release areas and one abandoned. Well, in this area, the firefighting trainings take place, and then one abandoned area. Colored dots represent the available sampling wells, and this is a site only polluted by PFAS. And groundwater analysis revealed PFAS concentration range from 45 nanograms per liter to 126 micrograms per liter, with the most polluted well, as you can see, is well 4. In soil samples, long-chain PFAS are mainly retained in the unsaturated zones, while short-chain PFAS increase with depth. The workflow to select the field test technology consists with different steps. Initially, a literature review was conducted to select the chemicals to be tested at lab scale. Initial lab experiments include batch tests using synthetic groundwater spiked with one single PFAS to assess degradation across different reagents combinations, reagents concentrations, and reaction time. The best performing chemical were then used with also synthetic groundwater, but spiked with a mixture of PFAS. Subsequently, similar experiments take place, but using real groundwater to readjust the concentration of the reagents and the reaction time. Next experiments include groundwater with soil from the case study 7 and column experiments. And finally, one treatment was selected to scale up to the field, taking into account not only the removal rate, also the associated cost, the byproduct formations, and the reagents consumption. Sorry, in this presentation, I'm only focused, or I'm only going to show you the results of the column experiments and the field tests. Two separate columns were performed, one using this reagent combination and another one using that one. Two punctual injections. Well, the experiment involved two punctual injections of approximately 200 milliliters of water, which contain the reagents combination, followed by a continuous injection of groundwater spiked with a mixture of PFAS. After the experiment, the two soil samples were taken, one near the inlet of the column and another one near the outlet, to assess absorption. Here are the results of the column experiment when using this reagent combination. As you can see, after the first injection and the second injection, a sharp decrease of PFAS concentration was produced, with degradation rates between 67 and 95% for undetected PFAS. If we focus on soil, as you can see in blue, the initial PFAS concentration of soil samples, in orange, the PFAS concentration in the sample taken near the inlet, and in green near the outlet. As you can see, the concentration of soil samples, these two soil samples, are higher than the initial concentration. So we conclude that sorption occurs. Moving to the other column, this is the results when using these reagent combinations. Also, I can see a decrease in PFAS concentration after the first injection. Results are less clear, but the degradation rates are between 40 and 100% for all detected PFAS. And also in soil, we can say that sorption occurs. With the results, we decide that the promising treatment to scale up to the field is the reagent combination of persulfate plus cerate and the field design or the injection. The field injection and the design of the injection consists of 2 sets of 3 injections at 0 hours, 8 hours, and 24 hours. We inject 200 liters of solution in sampling well 1, and we take samples or we monitor the PFAS degradation in sampling wells 2 and 5. Preliminary results, because we don't have all the results yet. So I'm showing the results of the first set of injections. As you can see, we can observe a decrease or a PFAS removal. If we see PFOS, we can observe a removal between 66 and 75%, but moving to hexanoic acid, removals are lower. This is due to that long chain PFAS breaks down to short chain PFAS, masking or treatment or reducing the efficiency of our treatment.
Well, good afternoon. And as Sònia said before, at the same polluted site, we evaluated another treatment train in the life source project. So based on-site pump-and-treat method, this approach combines 3 technologies: the surface active foam fractionation, the anion exchange filters, and the electrochemical oxidation. So as you can see in the diagram, so the polluted water from the wells was pumped and stored in a tank to feed the first the initial treatment step, so the SAF unit. And from the SAF unit, there are 2 streams. So the concentrated one moves on the electrochemical oxidation, and the diluted one that is directed to the anion exchange filters. Well, the physicochemical properties of the PFAS, mainly the hydrophobic and hydrophilic characteristics, are essential to understand the performance of the SAF. The SAF operates in 3 fractionation columns. In the first column, the air is injected at the bottom of the column, creating bubbles that rise through the column. So PFAS attached to these bubbles and forming a foam where PFAS are accumulated. So then the foam and the water removed are transferred to the second column, and the process is very similar, and the same in the third column. In the table, you can see the concentrations increase at each step. After that, the water from the SAF unit, the diluted stream, was treated in an ion exchange filters. We use two columns with two different resins. The first column was designed to remove only the cations to prevent the saturation of the downstream filter. And whereas in the second column, we use a specific resin only for PFAS until until achieving non-detectable levels. Well, the last but not the least, so is the destruction step. So we use an electrochemical cell with boron doped diamond electrodes, and doped diamond electrodes destroy the PFAS, but not only the PFAS, so the highly persistent chemicals due to the extremely high electrochemical potential. These are the results after the treatment. So the average value, the average removal rate for long-change PFAS was over 99%, meeting one of our KPIs. And regarding to the short-change PFAS, we obtain only 92% as average value, but we achieved our KPI in the last cubic meters that we treat. And the final, or the remaining KPI is related to the concentrations levels in the, so the concentration levels of PFAS in the groundwater. And well, as you know, so there is no legislation of PFAS concentrations in groundwater. And so for that, we use the values related to the Drinking Water Directive. Well, this is the contribution of both technologies, the SAF and the anion exchange filters. And in general, SAF remove mainly the long-change PFAS and needs a calibration step as a function of the initial concentration of the PFAS. Whereas the anion exchange are effectively at removing both long and short PFAS. Well, at this moment, we don't have enough results to decide which is the best alternative to the remediation of this site. If we consider only the removal of the PFAS, the alternative from the life source project achieves high percentage compared to the single injection of the Promises project. But of course, it's always the same. So each alternative has their own limitations and advantages. In that case, the alternative proposed by the life source project requires maintenance, be more expensive than the alternative proposed in the Promises project. And well, that's all. Thank you for your attention. And so if you have any questions, please let us know.